Good morning, friends. Today we are going to see the stacks and how they are useful and implementation of the stacks. So stack is one of the data structure that is used in the computer science in a different places. We can consider the stack as a list of elements in which each element is either inserted or deleted only at one end called as top of the stack. So stacks are called as last in first out data structures because the element inserted first will be removed last. That's why it is called as last in first out data structure or first in last out data structures. Whenever we are inserting the elements, we are inserting only at one position called as top. Always the element present at the top is removed. So that's why always the element that has been recently inserted will be present at the top of the list, so it will be removed first. There are two basic operations associated with the stacks. One is the push and the second one is the pop. Push operation is used to insert an element into the stack and the pop operation is used to remove an element from the stack, that is delete an element from the stack. And if you see the insertions and deletions, they are performed at the same end. So therefore, the last element that has been added will be removed first. And whenever the stack is created, the stack base remain fixed. When we are considering the array, we are considering the top as a -1. And when we are considering in a linked list implementation, we will be considering that as a null. So therefore, the most accessible element is the top and the least accessible element is the bottom of the stack. And now we will see how these particular stacks are used. These stacks are used in applications of computer science like functions. When a one function is calling another function or when the recursive functions are being used, the stacks are heavily used. As an example, suppose consider that function A is calling function B. So then the A is pushed onto the top of the stack and the B execution starts. After the B execution was completed, then only the function A is removed from the stack for execution. This we have seen here. When function A is calling function B, function A has been pushed into the stack and function B started execution. When the function B is calling function C, the function B has been pushed into the stack, and when the function C is completed, this function B comes out of the stack for execution. And when function C calls function D, function C is pushed onto the stack and the D starts its execution. And when the function D calls function E, function D is pushed onto the system stack. And when the execution of the function E is completed, then only this function D is removed from the stack. Now suppose consider that function E has been executed. Now the D will be removed, the top of the stack is D will be removed from the stack. This is the situation. And when function D was completed and its completed execution, the function C will be removed from the execution, that is system stack. And when function C has been executed, function B will be popped out of this particular stack. And when function B has been executed, function A will be removed from the stack. Like this, the system stack is being used for execution of the recursive functions or a function calling another function. Like this, there are different advantages and the different purposes of this stack in the system, that is computer science applications. Now we'll see the two types of representations that we are having for the stack. So stack can be represented either in a linear manner or in a that is linked list manner and in a sequential manner. In a sequential manner, you are executing the stack with the help of arrays. And in the dynamic execution or in the linked execution, we are using the linked stack. So at first we will see the sequential representation of the stacks, that is array representation of the stacks that we will be seeing. Suppose consider that I want to insert an element 2, that is I want to push an element 2. So it will be pushed onto this particular stack. Now if I want to push the 5, the top is incremented by 1 and in that particular place I am placing this particular 5. If I want to 7, on the top of this 5, I am pushing that particular 7. If I want to push the 9 on the top of the 7, I'll be pushing. That is, the push operation always, it will perform the activity of incrementing the top by 1, and it will be inserting the element at the top. And when we are implementing the pop operation, suppose consider that on this one I am implementing the pop operation, the element that is present at the top is removed, that is 9 is removed. And when once again I am implementing the pop operation, the element at the top is removed, that is 7. And when we are implementing the pop operation, the element at the top 5 is removed. And when we are implementing the pop operation on this one, the only the element that is present, it will be removed, and the top will be present at -1. Initially at this place top will be present at -1. After removal of all the elements, once again the top will be present at -1. Now if you see with another example for this one, suppose consider that 1, 2, 3, 4 elements are present, and the index we have started for the array is at 0. Now stack after pushing the 5, previously 1, 2, 3, 4 elements are present. Now the top is incremented by top plus 1, that is top now will be pointing to the 4th place. In that particular 4th place or the 4th index, the element called as 5 is inserted. Now suppose consider that I want to push the element 6. So now the top is present at 4, it is incremented by 1, that is top will become top plus 1, that is 5, and the element called as 6 is inserted at the top position. So in this way the push operation is implemented. If you see the algorithm, we are reading the number to insert, and if the top is equivalent to maximum -1, that is the maximum size of the stack. Because arrays is a static implementation, in this arrays we will be making the size of the array fixed. That's why if the size of the array is considered as a maximum, if the maximum -1 is reached, that is the array has been completed. At that particular position there was no place for inserting an element, so we will be displaying the stack overflow. Otherwise the top is incremented by top plus 1, and in the stack of top position I will be inserting that particular number. This is the way in which we are implementing the algorithm for the push operation. And the pop operation, if you see, this is the top that we are having. Top is pointing to the 5th element that we are having. Now if we remove one element, the top will be decremented by top -1, and the element is removed. So for the algorithm for this one is, if the top is equivalent to -1, that means if the top is -1, even the index is 0 also, there was no element, that means the array is empty. At that particular position we will be displaying the stack under flow. Otherwise we can display that element removed is s of top, and the top is equivalent to top -1. So the third operation that we are implementing, the peek operation. The only difference that we are having between the pop operation and the peek operation is, pop operation removes the element present at the top position, and the peek operation just displays the element that is present at the top position. So if you see the algorithm for this one, if top equal to -1, we are displaying the stack under flow. Otherwise we are displaying the element that is present at the s of top. This is the algorithm for the peek operation. And the second implementation of the stacks is linked list implementation. This technique has been used for creating the stack whenever we want the linked list to be, or stack to be dynamic. The creation of the stack using arrays is easier, but the only drawback is the array must be declared and it will be having some fixed size. If you know the size of the stack at the initially or in advance, the array implementation is efficient. But we cannot specify what is the size of the stack. In advance we may not be specifying what is the size of the stack. For that purpose we have the alternative representation of the stack, that is linked implementation. The storage requirement for the n elements is order of n. And if you take the linked list implementation, every node will be having the two parts. The first part is consisting of the data, and the second part consists of the address of the node. In the linked list will be having a start pointer. But when we are implementing the linked representation for the stacks, we will be considering the start as the top. All the insertions and the deletions are made at the top position only. Push operation inserts a node at the top, and pop operation removes a node at the top. In the array implementation we have taken, if the top is equivalent to -1, the stack is empty. Here we are considering if the top is equivalent to null, the stack is empty. So the push operation is nothing but insertion at the starting of the linked list, and the pop operation is the deleting the element at the start. Now if you see the linked list operation, push, pop, and the peek operations, this is the actual example for the linked stack that we are having. So top will always be pointing to the first node that we are having. So if you want to insert an element, it will be inserted before the top. If you want to remove an element, the top element is removed. The push operation. If you see the push operation, this is the linked list that we are having. Suppose now the starting of the linked list is pointed by the top. Now we want to push an element at the into the stack. So the element 9 has to be inserted before the top. Now what we are doing when we are considering this as a new node, the 9 as a new node, what is the mechanism that we are implementing is new node of next is pointing to the top, and the top is the new top is the new node that we are having. That is, I want to insert an element before this particular one. This is nothing but insertion at the starting of the linked list. If you see this one, I am reading the number to insert and I am creating the new node. If top is equivalent to null, that means there was no stack up to now. Our new node will become as the top of the stack. Otherwise, our new node of next will be pointing to the top, and the top is the new node. Okay, this operation is same as that of the insertion at the beginning, except in place of the start we have taken the top here. So this is the push operation implementation. I am creating the new node of the data. I am whatever the number that I want to insert, I am placing. New node of next is equivalent to null. This is the initial creation of the node. If the top is equivalent to the null, the top is new node. That is, whenever the stack is empty, the new node will become the starting of the stack. Otherwise, new node of next equal to top, and the top equal to new node. And the pop operation. Pop operation removes an element present at the top position. That is, top is pointing to the first node of the linked list. I will be removing the starting node of the linked list. That means top is making as top of next. Okay. So see, after removing the 9, the top now will be pointing to the top of next. Now if you see the pop operation, if the top is null, that means there was no element in the stack. If you are asking us to remove an element from the stack or the empty stack, we can't remove. At that particular place, we are displaying the stack is underflow, stack underflow. Otherwise, I am pointing the pointer to the top, and the top is made as a top of next, and we are removing the pointer that is present. That is, in the previous example, I am making the pointer as a 9. Top is pointing to the top of next. Now the top will be pointing to the 1. Now I am freeing that particular pointer, what we are placing at the 9. That means the node that we have created with the 9 will be removed. The function that we are writing, see here. So this pop operation returns an integer number. So we are taking this particular thing, see here. So if the top is equivalent to null, that is stack is empty, I am returning the -1. Otherwise, the pointer is pointing to the top, and I am taking the value as a pointer of data, because this is the value that I am removing. I am returning that particular value, and the top is equivalent to top of the next, and I am freeing that particular pointer, and I am returning that particular value. So the pop operation, what we are doing here is, the main thing that we are doing is top equal to top of next. Whatever the other 3 statements that what we have written, pointer equal to top and value equal to pointer of data and free of pointer, these 3 are used for the purpose of just displaying what is the value that we have removed and freeing that pointer. But only one statement that is very much needed is top equal to top of next. And the peek operation, if you see, it is just only displaying the top of the data only. That's why I am not specifying this particular peek operation. It is just displaying of the top of the stack that we are having. And if you see the applications, these are some of the applications that we are having: reversing a list, parenthesis checker, postfix conversion, and evaluation of the expressions, recursions, and towers of